Um, Greetings of the day, sir. This is Atharva K. Ayushi Verma, Pawan Bhatt, and Rohan Yadav, and we'll be presenting the game of chess and how alpha beta pruning is or can be used to solve the problem of playing chess. Uh, the reason that we chose the game of chess uh, is because since my childhood, it is a game that was considered uh, a factor of intelligence, and so I was always driven to play chess. And chess is one of the most oldest game in existence. Also, it was originated in India. So, for starters, the rules of chess are pretty basic. There are 64 squares uh, in the chessboard, uh, 32 white and 32 black. There are 8 ranks and 8 files. These ranks are horizontal and files are vertical. And this is a rook. The rook can move horizontally and vertically along the rank and along the file. And this is a bishop. Bishop can move diagonally and it can only move on the uh, color of the square that is currently on. So this is a white bishop. It can only move on the white piece, white positions. And this is a black bishop. It can only move on the black squares. So that is one thing. And this is a queen. And you can imagine queen as being the a mixture of both rook and bishop. She can move anywhere in these positions. Currently, it is working as a rook and a black bishop. It can also act as a um, white bishop like this, along with the same rook. Both queen, rook, and bishop can move. However, in any direction, as many squares they want to uh, as they want to uh, move on. One of the two of the most interesting pieces that we have left is a rook and a pawn. So let's start with the pawn. Here is the starting position of the game. A pawn can move one square or it can move two squares. A pawn can never, unlike other chess pieces, other that take on the location that they move on. Uh, um, the pawn cannot take the pawn cannot take in, in in front of it. It can only take a piece which is diagonally to it. So that is how a pawn takes. A pawn can never say, for example, this is a pawn. A pawn can never take like this. So this is how a pawn works. A pawn can only move two spaces in the first time it moves, and it can only take diagonally. Also, this is a knight. These can only these knights move in uh, L shape. So this is how you can imagine how a knight moves. So these are the squares that a knight can touch and move on. You may also imagine if uh, there are pieces along the along here. Uh, so a knight can pass. A knight can still move in this direction. So a knight can move here. Knight can move here. So basically, what I'm trying to say is a knight can jump with spaces. A knight can jump in spaces unlike any other piece. So imagine this is queen. So a queen can never move directly here. It needs this pawn to uh, it needs this pawn to empty the square in its place. So this was the starting position. This pawn needs to empty the square so that the queen can't move here. Okay, so generally, or uh, as per the standard valuations of chess pieces given by Hans Berliner, a pawn has a value of 1, a knight and bishop have value of 3, almost 3, and the rook is 5.1 and the queen is 8.8 in value. Uh, so um, also there is so this is a knight. It is value of 3 and self-explanatory as a piece has its value. There is also this thing that a knight placed here. Let's imagine, or it is placed here. These knights are not that much powerful because this knight placed here can only move on these squares, and placed here, this knight placed here can only move along these squares. And let's imagine a knight which is here, so it can move these places. Oh, sorry, that's not how it works. A knight here can move these places. So this knight can move along 8 squares, while the knight before was only able to move 4 squares. And also notice that this knight has very central location, while that knight was only uh, working on this area of the chessboard. So this knight is more powerful than that knight. Also, the same goes for rook. A rook with a starting position of a rook with a starting position with all the pawns here is not that much powerful as it cannot move into the game, and it can only move here, and there is no sense to move here. Uh, Generally, a rook which is on the seventh, eighth, and sixth file is considered strong, as it controls these major ranks. Also, for same goes for a bishop. A bishop pair which is uh, targeting the long diagonals is considered very powerful. So uh, these bishops are very powerful, and compared to a bishop that is let's say placed here, it can imagine. I mean, this is taking more space uh, than this than this bishop, and these bishop are dividing the board in half directly. Uh, Also, let's take one more example, last example of a king, and the king safety is the major thing. Uh, After castling right side, uh, the king gets to the space. So this square is considered a safe place for king. This space and this space are considered safe for the king. If the king by any chance is placed here or here, it is under a place where it can be targeted easily and put in check very easily. So, being on a king placed in the first rank and in these places is considered very safe, while the king being here is considered very unsafe. So, let's go into the code how we achieved this view with the help of min-max algorithm. And uh, so in the minimax algorithm, we take two player. One is max player and another one is min player. So the max player tries to maximize its uh, value, and the minimum player tries to minimize the game's result. So, as I mentioned, that each piece has its value. So, if I take a black piece, I will gain. If I take a black pawn, I will take one upon the black black player. So the and if a black takes my piece, it will take one down on me. So if so the so the black player is now plus one, and if minus one, and if white takes, the game is now plus one in the favor of white. So imagine a game in this. Imagine a game in the position of A, and the current game value is 3, and there are three possible moves that the black player can move. And so the white player will and the black player will choose the move order, which will in turn minimize the game's result. So in this position, we can say that the uh, um, higher score will be generated when max is 3 to 2. So the max player will play move C, so that it gives them maximum value to. Now we'll talk about alpha beta pruning. Alpha beta pruning is an optimized solution of min-max algorithm, and what it does is that it only calculates um, the nodes which are possible uh, possible or may or most likely to occur. So imagine in a place where both the situation are negative infinity and positive infinity, and the first value takes negative infinity and the next is 3, other one is 12, and third is 8, and this is 2, and going to this node is 40. So we this is the minimum players move. So we know it directly that it will move in C and 1 position, and that is how it's a it is so pruning. Pruning is pruning is a term which says that if a node is unnecessary, just prune it, like as in delete it. And so this is very self-explanatory, and a very optimal solution for alpha beta for the problem of chess. And there are the heuristics like pawn structures, the value of each piece, and number of moves uh, that a piece can take. Also, how the chess status and other special moves like castling and en passant. Uh, this is the Heinz Berlin relative piece value that I talked about before, and alpha beta pruning is that first search as we talked about, and uh, uh, it removes all the nodes that are too insignificant. So it eliminates unnecessary coding complexity and also reduces the time complexity. And in generally, it is noted that uh, uh, alpha beta pruning can reduce the time complexity by more than 50 to 60%. And the best time complexity of alpha beta pruning is b to the power d by 2, b to the power d. B is the branching factor, and D is the depth of the game tree, which is significantly less than min-max algorithm, which has a complexity of b to the power d. And here from the code, I will show you how an optimal and non-optimal opponent will play. So in this code, in this position, which I show you in the code, a player plays the game plays by random play and random player. You can see that it takes 270 moves, and in the end, the black player is only left with the king, and also the white player only has a knight and two pawns. This is very random play, as a general chess game only has 50 to 60 moves, uh, if a king and if only a black king is left, the white player should not take 270 moves to checkmate the opponent. And if had both of them played optimally and a little bit greedily, the number of moves and ending score should be better for both the players. And next case, we will take the idea of min-max player playing with a random player. So here you can see depth of 2 was taken for min-max player, as I have mentioned here. And by the end of 81st move, which is far lesser than 270 moves here, uh, the black player, which is random player, is checkmated, and the white player is left with a lot of pieces here. And as to be precise, white player is 31, 38 move, 38 scores ahead of white and black. And last, we'll see um, if both player plays optimally. Here you can see that it should be it should be like this. Uh, if both player play optimally, we can see that there are only 55 moves. Only the again the depth is only 2, and by the end of the game, white again wins. But the black also has significant pieces left, and the score in the end is plus 20 in the favor of white. So you can see that only only the depth of 2 can reduce and improve the playing of the chess, improves a lot of things. And if the depth was better, these games would have ended much sooner. But due to the computational limitations of my computer, we I could not go any deeper. Let me show you the code for this. So I used chess library, which is a library provided by which is open source library, which generates some moves and validation and some also common chess formats such as Crazy House and uh, Fisher 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 Random. And so here I created a board, which is a function which creates a board in the chess library. Uh, these are the legal moves in the first position. So you can see that these moves are the first moves that are very common. And now I created a random player. A random player plays any move that is possible in a situation and removes any illegal moves. Here you can see it only takes legal moves. Board.legal moves in again uh, a function which is defined in the chess library. I will be defining the alpha beta logic in this code, while if the chess in chess using a chess board and legal moves logic will be provided by the chess library. Here I have created a piece table for each of the pieces. As I said before, a king, a king, uh, king. Let's see, where is the king? Here is the king. King, a white king in its starting position is zero, while castle king is not safe. You can see this is the starting position of a white king. It is 0 0, while a castle king it might go here. It is plus 30 plus 20 and plus 10 30 30. And if a king moves into the third rank anywhere after the third rank, its value significantly decreases. Again, we say the same thing for the pawn. Pawns never start on the first rank, so it is 0. Uh, this is second rank, and the e4 and e2 and d2 pawns are most vulnerable. These are the pawns which start 95% of games for white. So these are generally targeted. So um, these places are more vulnerable. Um, these pawns are also uh, susceptible to trading, so that the bishop and the other pieces can move freely. And as the pawn moves forward, its value increases. As on the 8th rank, it becomes a queen. On the 7th rank, you can see it is almost valued 5 and vice versa. So, and the same, I have created a table for knight, the bishop, and rook. And if taken a look closely, it is very self-explanatory. I have defined it here as well, and I have also defined the value for each piece. Pawn is 10 value, bishop is 30, queen is 90, king is 900, 30 and 50. And I have created a function scoreboard which takes the current board position and takes the piece and its piece value as input, and uh, check it 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 checks if the current position is, is in check, so it improves the score and everything. Here I have created a function named minmax, um, and it uh, it evaluates how the current uh, game is going. It takes input of the current board condition, the depth that you are going to play, max player, alpha and beta, and for and it is containing logic for both max player and minimum player. And max player, you can see it is negative infinity, and for the minimum player it is positive infinity. And both of these functions will return max evaluation and best move for against max evaluation, and min evaluation best move against minimum evaluation. Here is the game that we are going to play. It defines which player is going to play, white or black. Uh, Display board is a function which is used to display the board like this. It is just a UI based thing, and This is play game function. It takes player types and visual type as inputs. And here I have defined the depth as 2. If I define it as 3, the computational power increases a lot. So uh, uh, board turn, you can see it is minimax. It takes current board, the depth is 2. It is board's turn. The alpha is negative infinity and beta is positive infinity. And the other is random player. That is how I have defined it. You can change it as well. And hmm, all the results are shown unless and until keyboard interrupt is given. Uh, it also prints the results if the position is in stalemate or five-fold repetition draw, insufficient material or draw claiming. And here you can see uh, a game is played between min-max and min-max as shown before. Um, uh, it is again a lot of pieces are left for both the game and white is plus 30. And also you can see that the number of nodes searched during the min-max algorithm was 4265. If we have done the same for 3 nodes, it would have been exponentially bigger than this. Here we have a game against the min-max and a random player. A random player is just left with a king at the end of it and only 89 moves. Um, the white is 38 points up, and here we again see a random player playing against a random player, and the position which is here is very absurd. King is not on a safe square, thus rook is not active, bishop is not active at all. This bishop is doing nothing for king safety. These pawns are doing nothing for king safety. So, and also this bishop is locked in its place. These are very random moves that are being played here. So that is how we implemented this. Also, major mention goes to Alpha Zero and Deep Blue. Deep Blue was a chess engine which was uh, uh, started to make in 1980s, and in 1996 it placed its first match against world chess champion Garry Kasparov, and in 6 matches it lost 4 games and won 2. In the year 1997, it again had a rematch against world chess champion and all-time highest, second highest player in the world, Kasparov, and it defeated Kasparov by winning 3 games and losing 2. The last one was draw, and this was a subject of a lot of appreciation in artificial intelligence history. And Garry Kasparov himself called Chief Blue Chess an alien, and one of the scientists that worked for Deep Blue also claimed that Deep Blue played like a wall coming at you, and the success of Deep Blue has been a major contributor to a lot of movies, and uh, it marked a reality in which was uh, imagined by Sir Alan Turing in his Turing machine. As again said, chess is one of the most difficult games that is in existence. It is only third to Othello and Go. And current best chess AI is DeepMind Alpha Zero. And I have given this quote intelligence beyond understanding. So in the year 2010, it was uh, Alpha DeepMind Technologies was was able to make the game, make the algorithm DeepMind. And in the year 2017 or so, DeepMind had 100 games played against Stockfish, which is world's best chess engine since then. And with only 9 hours of training, Alpha Zero won 25 game as black, 25 game as white, 3 games as black, and drew 72 of them. And it was again a major strike in artificial intelligence, as a chess algorithm only trained for 9 hours, beating Stockfish, which has years and years of database and training and funding as well, beating an algorithm so new, uh, and creates a lot of strikes. Even major world chess champions such as uh, Magnus Carlsen and a very famous chess grandmaster Hikaru Nakamura praised the games of Alpha Zero. After the arrival of Alpha Zero, the chess scene changed a lot. It changed how the games were being played, and in a nutshell, the game chess's meta was changed after the 100 games of um, Alpha Zero was made public. So, thank you for listening to this presentation, and I am thankful that we are given this chance. And the concluding our work, that AI is a field that has a lot that has achieved a lot in the past, and and entails a very bright future ahead of it. And alpha beta pruning is just a minor part of it. And in the future, we hope, and I hope personally, that it will take the idea of a Turing machine. Um, it will make the idea of Turing machine a reality. So let's see what happens. And thank you so much. Let me turn off OBS.